Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of substituted phenols depends on whether the substituent is electron donating, EDG, or electron withdrawing, EWG. EWGs stabilize the phenoxide anion, conjugate base, by delocalizing negative charge, increasing acidity, lower pKa. EDGs destabilize the phenoxide anion, decreasing acidity, higher pKa. Moving on to the next step. Identify the substituents in each option. A. Cl, para, weakly electron withdrawing by induction, though pi donor, net effect increases acidity slightly relative to phenol. B. Number 2, para, strong electron withdrawing group, both inductive and resonance, greatly increases acidity, very low pKa tilde 7.15. C. CH3, para, electron donating group, hyperconjugation and induction, destabilizes phenoxide anion, decreases acidity, highest pKa tilde 10.26. D. CN, para, electron withdrawing group, inductive and resonance, increases acidity, lower pKa tilde 7.95. Moving on to the next step. Rank by pKa, least acidic is equal to highest pKa. 4-nitrophenol, pKa 7.15, most acidic. 4-cyanophenol, pKa 7.95. 4-chlorophenol, pKa 9.38. 4-methylphenol, pKa 10.26, least acidic. And for the final step, the methyl group in option C is an electron donating group. It increases electron density on the ring and on the oxygen, making it harder to lose a proton. This destabilizes the phenoxide anion relative to phenol itself, resulting in the highest pKa among the 4 options. Why other options fail? A. Cl is electron withdrawing, net, so it increases acidity compared to C. B. Number 2 is a powerful EWG, making 4-nitrophenol the most acidic of the 4. D. Cn is an EWG, increasing acidity compared to C. Therefore, the correct answer is C. Therefore, the correct answer is option C.